So this is the next question, that is find the 8-point DFT of the sequence 11110000 using Dit Fft algorithm. So I've told you, right, first step is how much point is mentioned, that many lines you should be drawing, that many parallel lines. Okay, so now let's do like this and draw the. Yeah, so I've drawn 8 lines here, 1 2 3 4 5 6 7 8. Okay, so here input side, in case of Dit Fft, input side would be shuffled and output side all the terms would be written as it is. Okay, so here in input side, how the terms are shuffled, I would be first writing how it is. So first line x of 0 would be coming, then after that, since here in this case, in these kind of problems, since we have 8 lines, so how we can do is we can make a pair of 4. Okay, then we can make a pair of 2. That is, if we make a pair of 4, the next value x of 1 would be coming here in the 5th line, since this is one pair and this is one pair. In this pair only all the even values would be there. In this pair all the odd values would be there. If this is x of 0, in the 5th line we have x of 1. Then x of 2 would be coming in between these x of 0 and x of 1. That is in the middle line. That is, this is x of 2. Okay. Then here similarly x of 3 would be coming here. Okay. Between these two lines. Then x of 4 again here. Then x of 5 is here. X of 6. X of 7. And output side all the terms as it is, that is capital X of 0, X of 1, 2, 3, 4, 5, 6, 7. Okay, output side all the terms should be remaining as it is. This is one method. If you didn't understand this method, how to write this would be, if this is difficult for you to remember, one more trick is bit reversal process. Okay, that is input and output side we should be doing the bit reversal. So that is, first write here we have till 7, right? So if we have 7 values, so 8 bits, so we can write it in 3 bits, that is 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. So now what is this bit reversal is? Nothing much, reversing the bit, writing from right to left. Okay. So first thing is 0 0 0 as it is. Okay. So here see that, we can see that if we reverse the bit x of 0 and x of 0. So now x of 1, if we reverse 0 0 1, 1 0 0, right? So 1 0 0. 1 0 0 value is what? That is 4. So here we can see that x of 1 we have here and here we have small letter x of 4. Okay, like that this procedure goes on. Okay, so if this is 0 1 0, if we reverse it again, it will be remaining as it is 0 1 0 and its value is 2. So you can see that x of 2 and x of 2 we have here. Similarly 0 1 1, that is if we reverse it we would be getting 1 1 0, that is the value is 6, or the value of 1 1 0 is 6, so x of 3 and x of 6. Similarly, we have 1 0 0, that is 0 0 1, that is equal to 1. So x of 4 and we have here x of 1. Similarly, x of 5, that is 1 0 1. If we reverse it, it is 1 0 1 only. So we have 5 5 here. Then 1 1 0, that is equal to 0 1 1. If we reverse, that is the value is 3, x of 6 and x of 3, and x of 7 1 1 1. Right? So this is the procedure of bit reversal. Okay? If to remember the values are difficult here, this like this we can remember by using the procedure of bit reversal for 8-point DFT. So this is one simple basics. So now how to draw the structure here is, I told you right from the least, that is radix 2, so 2 power base n. So first value is n is 1, so 2 power 1 2. That is we need to be making a pair of 2. That is 2 2 2 2. 4 pairs are possible. First do the pair of 2 and draw the arrows like this. One is upwards, downwards, up, down. Okay, hope this is clear. Then wherever the downward arrow is there, mark it as -1 like this. And wherever the upward arrow goes in the input side, those values are w2 power 0, or we can write simply as 1 for all of them, since all of the values are w2 power 0 only. Okay, this is for set of 2. So now after 2 we should be drawing set of 4, that is, so how in 4 point we have drawn the set of 4 values, right? Similarly here, that is, leave 2 lines, and from the third line draw one upward arrow, fourth line draw arrow, it should be touching the second line. Similarly, first to third line, second to fourth line, downward arrows, mark it as -1. This is one set. Similarly, one more set, okay, draw like this. Wherever the downward arrow, mark it as -1, and in the input side, that is w4 to the power 0, w4 to the power 1. So this is for one set. For another set, again repeat the values, w4 to the power 0, w4 to the power 1. Okay, that is, this is 1 minus j, 1 minus j. Okay, hope this is clear. So we have made a set of 2, 4. Finally, we should be making a set of 8. Okay, that is, start from the 5th line here. So I have told you to leave the sufficient space, because this required a lot of space. Because if we write the values here of the first stage, second stage and all, you would be getting confused of which values we are considering. So leave some sufficient space. From the 5th line, draw an arrow upwards and it should be touching the first line. Similarly, from the 6th point, it should be touching second line. This should be touching the third line, fourth line. Okay, and the first downward arrow like this. Okay, like this you should be drawing for a set of 8. Wherever downward arrow is there, mark it as -1. Okay, and here the inputs of where the upward arrow meets, that is w8, because now we have 8 point, right? 8 point DFT, w8 power 0, w8 power 1, w8 power 2, w8 power 3. Okay, so now for these 3, right, we have a certain set of values. So now what are those set of values that I am going to explain you now. So what are the values of w8 power 0, 1, 2, 3? Okay, so let's explain that first. So if you remember this graph, I've explained you this graph, right, for 4-point DFT, right? So whenever we look and in a clockwise direction, 1 minus j minus 1 j, so these are the values of w0, w1, w2, w3, right? So this is for 4 point. So now in order to find the values of 8 point, draw one line like this. So here, after drawing lines, so now the values should be changing here. That is, if this is w0, in order to check for DFT, okay, you should be doing clockwise, and for IDFT you should be checking for, and you should be doing in anti-clockwise. Okay, that I will explain you. First, for 8 point, since we have 2 extra lines here, so if this is w0, this is w1, this should be w2 for 8 point, where I'll highlight it, w3, w4, w5, w6, w7, okay, in clockwise direction. So now, so we know the values of w0, w2, w4, w6, that is 1 minus j minus 1 j. So now what are these intermediate values for w1, 3, 5, 7? So the values are very simple. So this line here, it lies in first quadrant, right? So 0.707, 0.707 j, right? Common for all the terms here. 0.707, okay, for in these 4 terms, these terms are common, only the sign changes according to the quadrant. Okay, So this you might be knowing, since this lies in the first quadrant, both the axis is plus plus only, plus plus. So that's why plus plus. That is, this is the value of W power 7. Okay. Similarly, in the second quadrant, so this is the second quadrant. In second quadrant, we have one is plus and another one is minus, plus minus. So that's why plus minus. This is the value of W power 1. Similarly, for third quadrant, we have minus minus. So minus minus. This would be the value of W power 3. Similarly, for W power 5, fourth quadrant, that is minus plus. So minus plus. So this is the value of W power 5. Okay, like this you will be getting the values of all these terms. Okay, and if we see in clockwise, W power 0, 1, 2, 3, 4, 5, 6, 7, we are having all the values for 8-point DFT. Similarly, for IDFT, it is the reverse. That is, you should be checking from here anti-clockwise. So if this is W power 0, this would be W power 1 or W power minus 1, because we have IDFT, so W power minus kn in place of IDFT, right? So if this is 0, minus 1, this is minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. In case of IDFT, you should be checking anti-clockwise. In case of DFT, you should be checking clockwise. And these intermediate terms are common for all 0.707, 0.707G. Okay, you should be remembering that. And like this, we can remember the values of W power kn or minus kn for DFT and IDFT for 4-point and 8-point, both of them. Okay, so hope this is clear. So now with this, we have the values for this problem which you have left alone, that is W8 power 0, 1, 2, 3. We have all the 4 values, that is 0 is 1, so first term 1, and second term is W power 1, that is this term, W power 2 minus j, W power 3 minus 0.707 minus 0.707J. Okay, that values you should be writing here in the input side. Okay, that now let's write that now. Yeah, I've written all the 4 values. Omega W power 0 for 8-point DFT is 1. Then W power 1 is 0.707 minus j 0.707 according to that graph. Then next value is minus j, W8 power 2, and next W8 power 3 is minus 0.707 minus j 0.707. Okay, so this is the complete structure. Okay, so now the same thing with how we have solved for 4-point, right? The same thing we should be doing for this whole graph until we reach one answer here. Okay, nothing much to do. So first write all the input values. We have not written input only. The question is 1 1 1 1 0 0 0 0. So x of 0 first term is 1. Then x of 1 is 1. X of 2 is 1. X of 3 is 1. Rest all are zeros. Right? So we have 1 0 1 0 1 0 1 0. Okay, these are our inputs, and start from here now. This 1 would be coming here, along with this 0 into 1 is 0, so 1 plus 0 is 1. Okay, similarly now this 0 into minus 1 is 0, and plus, and this we have here one more 1, so 0 plus 1 is 1 again. Similarly 1, 0 into 1 is 0, 1 plus 0 is 1, and we have here 0 plus 1, 0 plus 1 1, then this 1 here, then this 0 here, so 1 plus 0 is 1 again, 0 1 minus 1, 0 into 1 into minus 1 is 0, plus this 1 is meeting here, so again 1. Similarly this is also 1 and 1. So here in the first stage we got all the values, answers as 1. Now the tricky part comes here, because we have these terms here, right? When we reach here, before that, let's do in the next stage, that is, this is 1 here, and here we have 1 into 1 is 1, so 1 1s are 1, so 1 plus 1 we are having, so that is 2. This 1 here, along with this 1 into 1. So if we meet these both points would be meeting here, so 1 plus 1 is 2. Similarly, now this 1 along with this term, that is 1 into minus j, that is minus j. So we have here 1 minus j. Okay, we got one complex term here now. So whenever we have complex term, we should be taking very careful and solving it. So next term is 1 into minus 1. So one term is minus 1. Then we have here plus 1, right? This is meeting here. So minus 1 plus 1, that is equal to 0. Okay. Next we have 1 into minus j into minus 1. Minus j minus 1 plus j. And here we have plus 1. So 1 plus j. Similarly, here we have 1. This 1 here. And here we have 1 ones are 1. So 1 plus 1, 2. And here 1. And here we have 1 into minus j. So 1 minus j. Right? Then here we have 1 into minus 1, minus 1, and here we have plus 1, so it is 0. Okay, this is plus 1, and here we have minus 1, minus 1 plus 1, 0. Then 1 minus j minus 1, that is again plus j, and here we have 1. So 1 plus j. In the second stage, we got all of these values. Okay. Then the final stage, again the same thing, this 2 and 2 ones are 2, so 2 plus 2, when it meets here it is 4, our first value is 4. Second we have 1 minus j, okay, and here we have 1 minus j into this term, that is we need to multiply these two now. Okay, in the Cal C, these two we should multiply, since these two are in the same path, that's why 1 minus I into 0.707 minus 0.707 I. If we multiply this, we will be getting minus 1.414 j. Along with that, we have here 1 minus j, right? That is 1 minus I minus 1.414 I. That is equal to 1 minus 2.414 j. Okay, hope this is clear how I got this. This is the second value. Similarly, third value, here we have 0 and 0 into minus j is 0, so third value is 0. Fourth value is 1 plus j, and these two values would be getting multiplied, that is 1 plus I into minus 0.707 minus 0.707 I. That is minus 1.414 I again. Along with that, 1 plus I, that is 1 plus I minus 1.414 I, that is equal to 1 minus 0.414 I j. This is our next value. Okay. Similarly for these four values, that is here we have 2 into 1 into minus 1, that is minus 2. Along with that, this 2 here, so minus 2 plus 2 is 0. Okay. Next value is 1 minus j into this term into minus 1. These three are in the same line, so these three also would be getting multiplied, and this term into minus 1 is, these two signs would be changed here. This is minus 0.707 plus j 0.707 because we are multiplying it with minus 1, right? So that's why 1 minus I into minus 0.707 plus 0.707 into I, that is equal to plus 1.414 I. Okay, here we have, along with that we have 1 minus I. So 1 minus I plus 1.414 I, that is 1 plus 0.414 j. Okay, so here again 0 into minus j into minus 1 is 0, and here we have 0 only, so 0 0. Our final value is 1 plus j into this term into minus 1. So if we have into minus 1, these two signs should be becoming plus now. That is 1 plus I into 0.707 plus 0.707 I. That is equal to plus 1.414 I. And here we have 1 plus I. Okay, so 1 plus I plus 1.414 I. That is equal to 1 plus 2.414 J. So that is our last value. Okay, I know that I've taken a lot of time, but in order to explain you guys, it is very necessary. So this is the complete 8-point DFT structure here, and this is the answer here. Okay, final answer you should be writing that x of k sequence here. So I'm not writing that. Hope you would be writing it. I hope that you might be writing it. So this is in the order. So this, like this, you should be writing the sequence final answer, because if you don't write that, you won't be getting marks. Okay, so these are all are the answers of x of 0, 1, 2, 3, 4, 5, 6, 7. Okay, you can check it out later. Okay, please try to solve this without any reference, without first see the video, completely clarify everything, then try to solve without seeing. Okay, because these kind of problems are fixed questions. DFT, DIT, FFT,